just start the live stream. One moment. So I'm just going to close that while it records. All right. So, all right, welcome everyone. My name is Pavan Nandakishore, and I'm really glad to have with me Serge Massis, Macy's. Macy's, sorry. Yeah, so okay. I'm just gonna let him introduce himself. But before that, one piece of introduction that I do want to do about him is he is the author of Interpretable Machine Learning with Python, was published by Pact. And I would highly advise you guys to pick up his book. I've ordered a copy for myself. And it's going to be really interesting because he's going to be telling us exactly about that. He's going to be telling us about why AI startups, not just big organizations, need interpretable machine learning. So it's going to be an interesting talk. So the format is going to be he's going to tell us why interpretable machine learning is important, and then once he does, we can ask questions. Feel free to also just ask questions along the way in the Q&A section. If we get a chance during the talk to sort of address some of those questions, we'll address those. If not, at the very end, we'll address many of those questions. So yeah, with that, I will let Serge take it away.
Hi guys, how are you? Let me set up this thing. I have to set up the sharing first. So bear with me. Where is it? I have probably a bad habit, a lot of windows open. So there.
That does tend to happen quite a bit.
Yeah. Okay, so you see my screen now, and I'm going to start the presentation. All right. You see that? Yep.
Yeah. We can't see the presentation yet, sir.
Oh.
There we go.
Oh, okay. All right.
It might be a lag or something, so yeah.
Yeah, it took a little bit. All right. Thank you guys for joining, first of all. And great, thank you for the introduction, Pawan. And well, for those that don't know me, because I know a few people here. Oh, there it is. Okay, let me quickly introduce myself. My name is Serge Massis, as Pawan said. Serge is actually my English nickname, but you call me Sergio if you speak Spanish. I'm a data scientist at Syngenta. I work on food security problems for the Climate and Agronomic Decision Science Department. And for the last 8 months, I wrote a book for Pact. Well, that wasn't the last name, so this is old introduction. But over the last year, I wrote a book for Pact, which is a comprehensive hands-on overview of interpretable machine learning. It was just released a few months ago, and it's available on Amazon. This is actually my second career. For over 15 years. I was a full stack web and app developer, a webmaster, and even the founder of a search engine. In these roles is how I got into analytics, since the internet is often the source for big data. So without further ado, let's dig in. So this session is broken up into 4 parts. First, a story, then what is interpretable machine learning and how to overcome, and then followed by how to overcome the unique challenges for AI startups using interpretation to guide you. Lastly, I speculate as to what's in store for machine learning and why that's helpful. Okay, so I will start the story, which I will connect with interpretable machine learning. So bear with me. It's about my wonderful startup adventure. So actually, it's one of these stories that starts by telling you the sad news that the main character passed away. So indeed, my startup is in the startup graveyard. Rest in peace. I wish to say it died of natural causes, but because it failed to take off before it ran out of a runway. So pretty much, fell off a cliff sort of situation. It was actually a search engine. And so a search engine for what, you ask? It's a search engine for activities to do right here and right now. Activities are things to do that are either places to go or events to attend. and these are like leisure things. And there are four major categories for activities we had: food and refreshments, sports and recreation, nightlife and entertainment, and education and culture. So using it was simple. Just shake your phone and get an unordered list of 7 activities. You can change the filters to change time, radius, category, and much more. If you swipe right, you put activities in the bucket list, whereas if you swipe left, it removes them from the results. If you click on any activity, you get additional details, which you can share via email, Facebook, or whatever. But considering there were so many apps and search engines available, including Google, what was the value proposition? Why was this an important thing? So this is our pitch. It was that existing solutions made choosing harder. Starting with, to gather all activities available right now, you would have to search in multiple apps. Sifting through the results would be a big time investment. Over time, search results changed very gradually, and ranking based on ratings, reviews, price, or other details made them lack diversity. And this wasn't fair to businesses, and it wasn't exciting for users. In other words, they were relatively static and uniform. They also lacked personalization, meaning different people would get exactly the same results or very similar ones. Sifting through so much data made looking for activities overwhelming, while lacking of interesting, surprising results boring. So Shufflix would make choosing easier by countering each one of these pain points. Single app instead of multiple app, time saving instead of time consuming, dynamic and diverse instead of static and uniform, personalized instead of wisdom of the crowd driven, low cognitive cost instead of overwhelming, fun to use instead of boring. So developing the app came with its fair share of technical challenges. I'll share 2 of them that involved machine learning. Shufflix would return 7 shuffled results at a time. If the results were entirely random, paradoxically, there would be no variety. This is because data fluctuated over time and placed very unevenly, and certain categories, such as restaurants, dominate. As you can see, the intention is to combine places and events that are representatives of those in the data, but not in the same distribution.
That's really interesting. Hello, sir.
So, yeah.
Yeah.
So you have a question?
Yeah. Just a question. So, here in the previous slide, right? Mm-hmm. When you talk about events, places, so those are the only 2 categories in terms of activity types.
Yeah, pretty much, because there were deals. There was a 3rd category, actually. Okay. I wrote this, but deals were like very seldomly used and depended on the area because there was a lot of junk for deals. So deals, like sites like Groupon have deals. Yeah. There's a lot of different sites like Groupon, and so we would aggregate activities from deals. The problem with deals was that there was a lot of spam. There was like a lot of garbage there. So sifting through them meant that even though there was an overwhelming amount of deals, they were like 0.5%, no, probably 0.1% in some cases of the results. So it was really hard for you to see them, and they were very low value. So depending on the area, if there was a high quality segment of deals, they would show up in the pie as something worth. Otherwise, they would be filtered out because there was, before it even got to this, there was a quality filter.
I see.
Yeah.
Awesome. Thanks.
So to solve the problem and ensure variety while capitalizing on the power of randomization, results are pseudo-randomly picked from 7 independent clusters of activities, which encapsulate both places and events. The inspiration for the solution was a Wired article on how dating app OkCupid works. So OkCupid works with this method called K-modes clustering, which is K-means, but for categories. So it's very interesting. But yeah, that's how we solved it. So The second problem I'll talk to you is about even after we filter out unpopular activities, there are also activities that are unsurprising or offensive. For instance, there's nothing surprising to be offered to eat a meal at a McDonald's or a Golden Corral. People may like these places, but we don't think they would have this in mind when using our app because they're looking for novelty. And there's just simply nothing novel about them. As for offensive, a gentleman's club is an activity many like, but it's not something we should just offer to just about anybody. Of course, offensive is in the eye of the beholder, so a profile would allow a person to state their preferences that they are vegan, so they would never get offered a steakhouse, even if they were surrounded by them. In addition to unsurprising or offensive tags, there are also expensive and for kids tags, among many other. And we realized the way to use these tags was like this. We personalized newsfeed, like personalized newsfeed algorithms use engagement. This is like a separate kind of thing that is very similar in architecture, but different in philosophy. So you got personalized newsfeed algorithms that use engagement to train models that predict how likely a user is to engage with certain content, and then rank based on that. And that's how the news feeds in Facebook work and LinkedIn and Twitter for the most part. And our ML Solutions personalization engine didn't use ranking based on probability. Instead, it learned weights, which are like odds, not probabilities. So, however, tags were used to fill in the initial weights so that some activities would never appear while other were contingent on preferences and behavior. The tag weighting would get multiplied by the personalization weights. Then it would shuffle activities using the combined weights. So imagine you're shuffling like a bunch of lottery balls, in like this big spinner. And the concept behind weighting is imagine if some of those balls weigh more than others. So logically, the balls that weigh more than others are going to have a bigger chance of falling through the hole and getting, caught by the person that picks up the lottery number, right? So that's the concept behind it. So anyway, these two machine learning problems only complicated things. When beta testers would send back print screens with strange results, or my co-founders would tell me that the app crashed, the natural thing for me would be to load the user session to debug what happened, tracing it to every line of code and variable. However, quickly I realized that debugging machine learning models is not at all like debugging software. Sure, you can derive performance metrics, which in aggregate tell you how well they do, or you can understand how the model works in general, but you can't be absolutely certain that it did what it did was supposed to do to begin with. So it's really tricky. So this was a big departure from my engineering mindset, which was for the most part deterministic. A model was, after all, like software, ones and zeros, and they determined through a series of steps how an input be transformed into an output. That was my thinking. But what I didn't understand is the way these steps were derived was not deterministic at all. As we all know, there's a stochastic nature to the training process. Furthermore, in many years in web and app development, I was used to performing unit tests and stamping like my seal of approval on deliverables. How could I guarantee to stakeholders that my product worked as expected every single time if I didn't understand what was going on under the hood myself? And so this is the story of how I became interested, nay, obsessed with interpretable machine learning. So what is interpretable machine learning? First thing to know about interpretable machine learning is that it's also known as explainable AI. There's some debate about this, but I think it's my opinion that they refer to the same thing. And people are just trying to redefine what people already use interchangeably. One stems from academia and another more from industry, but they're used interchangeably, as I said. I prefer the term interpretable machine learning, so I'll be using this term more throughout this presentation. The second thing to know is that they've become increasingly more popular over the last 5 years, as evidenced by these Google trends. Likewise, during this same period, there has been more and more mentions in books for both terms. However, the mass majority of these books have been either non-technical books for business audience, books about AI ethics for AI ethicists, and or academic compilations for people that actually work actively in research in this field. Practitioner-oriented books on the subject can be scarce all these years. In fact, my book, published only 4 months ago, was the third one ever. Thankfully, by mid-2022, there'll be 6 more books on this subject. And so the main concepts of interpretable machine learning are fairness, accountability, and transparency, or FAT. Some say FAT, but I say FAT. You expect the machine learning model to produce fair predictions. They must be robust and traceable back to something or someone, and should be able to understand how they were made. And there are many concerns associated to these concepts, grounded in ethics. And ultimately, what we want to know is super practical. It's not even moralistic. It's, can we trust the model? And can we make the model more trustworthy? Because trust is mission critical. You want to trust products, you want to trust people, you want to trust decisions.
So sir, just sorry to interrupt once more. So you showed it as a pyramid. That's interesting. Why a pyramid? Is it just that the bottom layer is easier to achieve and fairness is harder to achieve?
Exactly. Yeah. Okay. It's because it's easier to achieve and it's more top of mind. Like when you're at the bottom of a pyramid, that's what you see. Kind of the top is over there, but you immediately see the bottom. And when people think of interpretable machine learning, they're often thinking about explainability, interpretability, things like that. They're not thinking about privacy, fairness, and all that. I mean, it's part of it, but most of the literature written about interpretability is on that bottom layer. Additionally, that bottom layer is the low-hanging fruit.
Yep.
So that's a paradox. And on the other hand, when you asked AI ethicists what worries them about machine learning or AI, they're worried about fairness, they're worried about privacy, they're worried about reliability. That's what they're worried about. Stuff more on the top than on the bottom. But of course, you need the bottom to get to the top. You know, you do need that. It's not like you don't. It's not like it's not important. It's just it's definitely easier to get to. According to my definitions of what it is to interpret a model, because there's people that think, oh no, to interpret a model, it has to be a white box model. It has to be, very simple, and it has to be like almost pretty much a rule-based system, and that's too stringent for me. And plus, it's impossible, in many cases, So I can talk about it a little bit later, but the concept I ascribe to is post hoc interpretability. So it's fair to ask, is interpretable machine learning and ethical AI the same thing? And not really, but both concepts overlap. Ethical AI, also known as responsible ML. I mean, there's a little bit more debate here what exactly differences them, but they're almost overlap exactly. It includes data and algorithmic governance aspects. These aspects include privacy regulations, data management procedures, and even modeling standards. They also uphold FAT. In other words, they also encompass aspects of fairness, accountability, and transparency. On the other hand, interpretable machine learning is how we can implement fairness, accountability, and transparency with machine learning. However, and this is more like something for machine learning practitioners than like other professionals. They're definitely involved, but they don't implement it. However, these very same tools used for ethical reasons can be used with no ethical reason in mind, simply for curiosity, and they could also be used unethically too. Obviously, someone interested in fooling a machine learning system can pick up an adversarial robustness tool and figure out how to do that. Ethics aside, we have to ask, why do we need interpretable machine learning? machine learning interpretation is needed because machine learning by itself is incomplete as a solution. Think about it. Simple problems could be likely solved with procedural programming. Solution covers all of it. The complex problems we optimize with machine learning require linear algebra, calculus, and statistics, precisely because we don't understand all the problem. By explaining the decisions of the model, we can cover gaps in our understanding of the problem. In other words, its incompleteness. One of the most significant issues is that given the high accuracy of machine learning solutions, we tend to increase our confidence level to the point we think we fully understand all the problem. Then we're misled into thinking our solution covers all of it, which of course it doesn't, because it's simply an optimization. So let's speak a minute about complexity, because it's often to blame for issues of transparency, accountability, and fairness. I would say rather unfairly. I mean, of course, you have a trained white box model can reveal intrinsic parameters such as mathematical formula, weights, a tree, or coefficients that can be easily understood. These simple mechanisms make them interpretable with very little effort. On the other hand, a black box model is not as impenetrable as you would think. It's just much more complex. It's this complexity that gives it an edge performance-wise, but also makes it less interpretable, by no means impossible. After all, we can't explain exactly how a human brain makes a choice, yet we often trust its decision, because we can ask a human for their reasoning after the fact. This is why so-called black box models can still be interpreted through post hoc interpretability methods. Model complexity does impact FAT, but the data should also share the blame, because obviously the data is riddled with all kinds of issues. So how do I use interpretable machine learning? These are the most common diagnostic interpretation methods and tools. Notice that predictive performance is only one of many. Of course, like that's what most people are aware of and what they use to guide their machine learning endeavor. After all, you have many methods that focus on also global understanding of a model and others on a local understanding, in other words, of a particular prediction. And some methods can relate to both. Some go beyond transparency and specialize in other model problems such as fairness, uncertainty, anomalies, adversaries, privacy, and so on. So there's a flip side to the diagnostics, and how do you fix issues you find with the diagnostics? We have things we can do to the data and others to the model. Complexity is one of the biggest enemies of interpretability because with so much noise, it's hard to hear the signal. We can reduce the amount of features in the data set or introduce regularization to the set. Also, even if the data is relevant, the model might learn the wrong thing from it, which is why you need to place some guardrails to help point it in the right direction. This can be achieved through creating features that capture noisy interactions going on in your data, or placing monotonic constraints so that the independent and dependent variable relationships always go in one direction. Bias is also not only on the data side, but also when precision is more important than recall or vice versa. That's when cost-sensitive learning can help align your predictions to your mission, be it safety or fairness. Lastly, you want reliable predictions that can withstand unexpected scenarios, be it from natural anomalies or from coordinated adversarial attacks. So, and then also to ensure privacy when needed. Incidentally, there's also a third column for inference, but we won't discuss that here. So there's something that can be done to fix models even after they've been trained. As far as interpretability goes, the choice is yours. You can be a daredevil, chase after a single metric and just hope for the best, or through better instruments and understand the data conditions better and tweak the model for safer, and both the model and the data for smoother, safer, and more reliable operation. I choose these two pictures because it seems to be like we're often using this very simple plane on the left to pilot machine learning, when we have all these other tools we could use, like the plane to the right, to pilot an even better AI. Lastly, also, let's stop making predictions about only following trajectories, but even possibly changing them. There's a fitting quote that says the best way to predict the future is to create it. And I'm a strong believer of that, especially when it involves fairness. Like we take biased data and turn it into even more biased models. Uh, we can completely correct that trajectory and essentially change the future, regardless of what the data says. So I think that's a very important point to make. So startups have unique challenges. I recognize that put them in a disadvantage with established competitors. The next few slides are a collection of ideas that can help an AI startup not only overcome challenges, but possibly even gain an advantage. Many of them involve interpretable machine learning, and of course, some do not, but they're just based on my own experience. So first thing is startups receive a lot of pressure to iterate and deliver a product quickly. Initially, this might be the minimal mile product, but it could be the second or the third or the fourth release. The point is, this translates to a sloppy, minimal viable model, which as soon as it proves good enough to be is rushed into deployment. What I recommend is to focus on sustainability, because given how tight deliverables are, you don't know when the next time you'll have an opportunity to retrain a better model. Also, unlike software, models aren't as visible and modular, so you have to be very deliberate from the get-go. Which brings me to the point about deployment, which is essential to anticipate future needs with the model and its maintenance. Whatever you do, don't cave from the pressure. Now I explain how to overcome both challenges independently. So to train a model that proves sustainable, I suggest the data-first approach, where the focus on data quality rather than quantity, making the sparsest model rather than a beast of a model. Then leverage interpretation methods to understand what's going on as best as possible, and validating with domain knowledge. Lastly, hyperparameter tune with generalization in mind. As for deployment, you make sure you have all the MLOps infrastructure in place from the get-go. This means versioning, uh, anomaly detection, feature and concept drift, and the logic not to deploy models that don't outperform or perform just as well as previous models. Ideally, models have an expiration date assigned to them. I've also added this one, which is seldomly used, which is including in the pipeline global model interpretation methods. Such methods include CHAP, or they could include something like integrated gradients, aggregated. If it's a time series model, that could be useful. It really depends on what your model is, but you could incorporate such a thing, and then based on that, you can understand if there's been a difference. Especially good for data drift. There's been a difference in what the model considers important, because consider this: your model may be right. It may be right today, it might be right tomorrow, but tomorrow might be right for the wrong reasons, and you want to know when that happens. So another problem faced by startups is that, given that they're new, is that they don't know what usage their products will have, and therefore unforeseen outcomes their model will produce. Therefore, I recommend 3 methods from the machine learning interpretability toolset. The first one I've already mentioned is enforcing model constraints so that outcomes don't contradict domain knowledge. Employing adversarial robustness tools to both test the model for its robustness, but also train a more robust model. And if uncertainty is a factor in your industry, sensitivity analysis allows you to find the inputs that create the highest uncertainty in the outputs of the model. And this is very useful because it allows you to anticipate what features you have to watch out for. Especially when it comes to feature drift, you have to be very careful for that. So say your startup has few users or customers to work with, which means less data and a lot of assumptions to fill in those gaps. How do you make decisions regarding other yet unknown scenarios? For instance, the financial benefits or risks of rolling out a new offering or comparing several options to see which one would perform better, or making a more informed guess of what product a customer would prefer based on preferences of beta testers. Ways to solve this include using beta testers as guinea pigs and performing A/B tests, or perhaps you need a multivariate simulation instead to understand what offering would work best with individual customers. However, what if there are many variables and several conflicting, overlapping offerings, and maybe even confounding variables? In the parlance of causal inference, this is called a treatment, and you could decide what treatment to offer to each customer based on a causal model. And I highly recommend this. If this is the case, it will allow you to make more informed decisions in regarding where to take your product next. So another problem is startups have no brand recognition, so they have essentially no trust from users. One way to gain it quickly is through transparency. And you can tell the machine learning interpretability toolkits provides many ways to offer assurances to new users, such as certifiably fair or robust decision making. Mind you, this is still in like initial test, initial adoption, but researchers have found many ways of doing this. However, one of the simplest way to offer this is through local model interpretations upon making the prediction to users. So you make a prediction and you show them why you made that prediction. Say a credit agency could offer applicants a reason why their credit was denied, or a fledgling new startup, self-driving car startup, could show beta writers what the car sees in real time. And then, lastly, I wanted to end this with a positive note. Creating a startup with big data and AI was challenging back in 2015. And even though it's improved, it still is today. But I believe it will get better quickly and fairly soon. And so the reason I know this, because I've been here before. Some of you might be too young to remember 1999, but it was the year of The Matrix, The Fight Club, SpongeBob SquarePants, Britney Spears, Star Wars Episode 1, and the craze for Y2K. I was still a teenager, but it was the year of my first paid job. I was a web developer back when most people dialed up and websites looked like this. And browsers were so different, you had to tailor websites to them, and they could look entirely different or not work at all on different browsers. Yeah, so I also learned to code HTML by hand before web development software made it easy to do with drag and drop or higher level coding that abstracted. Then came data-driven websites that I would do with Perl, Cold Fusion, Java, and PHP with databases in Oracle, MySQL, SQL Server, and MySQL. Back then, if you wanted a content management system, an e-commerce site, or customer relationship management system, you would have to code it from scratch, and I did. So when I see code of hand coding data preparation steps, model training, and evaluation in Python, it takes me back to the days where all websites were custom, artisanally crafted. And who among us does not get giddy in anticipation while a model is training? This takes me back to when we made it a few minutes while our website page loaded, or even while we saw our websites load for the first time. That feeling is one we now take for granted. But when it doesn't work, we spend a lot of time configuring libraries that become incompatible, debugging minor issues, and looking for answers on Stack Overflow. This takes me back to days where website content could make a browser crash and become easily unstable with a new version. But I believe this pain is just temporary, because what if I told you the future of AI and machine learning is low code or no code? And the reason this is important is because as soon as this happens, more focus is going to be on the interpretation. All those people that are in this because they see it as an extension of programming, they have to start seeing the statistical side of this and taking it more seriously, because that's where the skill set will be. It won't be in be able to program all the steps necessary to, transform data or to train a model, but all the stuff that comes after and during the process that really needs some attention, all the instruments in the plane, you know. So that's why I equate it to flying a plane. Flying a plane used to be like a very manual process, and now it's just a collection of instruments and a guy that sits in back most of the time, just looking at those instruments. That's what I think machine learning will become. So, and much like everybody and your grandmother can now create websites in an idiot-proof interface and deploy it with one click, reliable models will be able to be trained and deployed just as easily in a few years. Soon enough, writing code to train models with Python will seem as quaint as writing HTML code to create websites. So trust me, it'll get easier. And now a shameless plug about my book. It just came out 4 months ago. It's 14 chapters. There's Python core, of course, and lots of visuals, but without excluding theory, which is very much needed to be able to interpret the outputs. What makes it unique is that covers both interpretation methods and solutions for interpretability issues, which is something not addressed in any book so far. Also tackles interpretation specific to deep learning and non-tabular data. I also have avoided any hello world examples and the use of toy data sets, which most data scientists have already seen 100 times and lacking context. The reason for this is I use plausible, fully developed example that have a backstory, which I call the mission. In data science, the how should never be disconnected from the why, I believe. Anyway, there's an exclusive discount for anybody that wants one. It will be active for 5 weeks more, and there it is. I can copy it in the chat if you're interested, and I'm open for questions now.
Awesome. So people are, I encourage people to just post their questions, and we can address them as we go along. But as as people start doing that, let me ask you a few questions. So Serge, yeah. So firstly, thank you so much for this great talk. This is awesome. I think there's a lot that we learned out of it, and I think one interesting thing that you mentioned was about sort of low code and no code machine learning, right? So wouldn't these sorts of interpretability methods be incorporated into that system as well?
Yeah, they have to be. I mean, at the moment, that's why I don't. I mean, I've used AutoML tools, but so far, none of them have convinced me as having the potential to supplant a data scientist.
Okay.
And it's not like data scientists will ever be gone from the equation. I think it's supposed to make our jobs easier, and at the moment, it's skipping so many steps. I don't think it really is. I think it just takes care of hyperparameter tuning, and that's it. And it gives us overconfidence that it's done. It's a fully baked model. It's ready to go, but it's not. I think there's a lot of steps that come before and after that are pretty much needed to make it complete. And until like AutoML solutions incorporate interpretability and interpretability methods bake them in, it won't be like that. And honestly, I don't think it will ever be like press a button and it's done. For a lot of use cases, there'll be a lot of like red flags popping up and answer this question and we found this. Is this correct? And there'll be a lot of that, I think, in the process, and there should be, because data is messy, and so we need to be careful about those things. So I think the low code and no code will happen. I think it's happening already. There's a lot of tools that I'm taking note of when I say, they have these good features, but there's still a roadmap. There's a few things missing for it to be like, my pipe dream of machine learning interpretation, cockpit, if you will.
Yeah. So actually, we have a question here. What do you expect the story would be different with deep learning?
What to expect the story to be?
difference with deep
Y-
learning? I guess
Yeah.
in this
Well,
context, it's yeah,
my
for
story or the story in general, I don't think it's much more different. I think there's different methods.
okay.
Deep learning, the problem is there's obviously an abundance, at least when it comes to unstructured data, of local interpretation methods that's like interpretation methods that focus on individual predictions. And there's lacking a lot of global interpretation. Uh, Obviously, because it's unstructured data, there's no like formal connection between features. So I would expect this to be very different, but there's already tools out there that are trying to address that,
Okay.
and they're very promising. But that's the thing; they have to be visual tools that
Yeah.
kind of
Yeah.
establish a pipeline of and show you visually what's going
Where
on
it's
in the model.
failing. Yeah. Yeah.
Yeah,
And I know that, for instance, in computer vision, like grad cam, saliency maps are quite
yeah,
heavily used for this sort of purpose.
yeah,
So yeah, yeah. So I think that's something that definitely is quite prevalent. I know that there's been also like a lot of NLP tools that visualize the output of LSTMs to understand like, okay, where, where you might have information bias and whatnot.
yeah.
So yeah, that's a very good point. So we have another question. Can you give more detail on why ML interpretability and explainability are the same? Any reason why a lot of practitioners call them two different things?
Mm. Well, the thing is, the first thing to know about those things is that, well, I distinguish between interpretability and explainability, but I don't distinguish between interpretable machine learning and explainable AI because those are used interchangeably, but interpretability and explainability strangely aren't. There's a lot of literature that distinguishes explainability from interpretability, and I think the difference is in the level of transparency you want. In other words, do you want to be able to understand exactly how the model works? How does it make its predictions? How did it arrive to a set of coefficients and biases and so forth?
Yeah,
Or is that irrelevant? Do you
yeah,
want to treat it as a black box?
yeah,
That is that's a clear-cut difference between explainability and interpretability. I see interpretability as a larger, like if this was a Venn diagram, interpretability would encompass explainability. And explainability is just something that enriches uh, how interpretable a model is, that you can actually get to that level of explanation. But for a lot of use cases, I find it not necessary, to be
yeah,
honest, because like if the purpose of AI is to enhance or replace human decision making, and human decision making is a black box. I
yeah,
mean,
yeah. That makes sense. That's
it
a
doesn't really
interesting point.
matter. I
Yeah,
mean, the only difference is that machine learning is built with correlations, and we want causal explanations, and we
yeah,
can't get that out of a machine that is, a correlation machine. So we, that's why I think the field of causal modeling is so promising. And there are some inroads as far as making causal explanations, even out of our black box models. So that's a very interesting field of research right now.
yeah, yeah. So that actually, so okay, there's another question. Then I'll talk about a little observation I made in one of your slides. So using your information retrieval slash search ranking use case, what are some of the reason what are some of the reasoning and explanation techniques you find useful in that domain?
In that domain, that's interesting. Well, the first one was the first model I showed was a K-pose model. That's an unsupervised method.
Yeah.
So it's very tricky to actually explain.
Okay.
Usually you just try to see what's clustered in those different clusters and find some commonality between them. And it tends to be very intuitive.
Hmm.
And it was. And that wasn't even the most difficult part of it. I think that the second problem with the weighting, that was more problematic because there were just so many factors that came involved in the weighting. Like every swipe a person did could impact that weighting. You know,
Yeah.
every preference they chose could impact that weighting. So uh, I think I if I had to take this use case and derive a lesson from it, I say I made it way too complicated too soon.
Yeah.
I shouldn't have done that. I should have found a simpler form of doing it. But uh, to answer your question, um, for that algorithm, I think it was completely it was sparse. I think I used SVM. Yeah, I used SVM.
Okay.
Um, I could have probably used some. I could have probably used Chap for it actually. Now that I think about it, but I didn't. I think I was barely aware. Chap. I don't think it was even. I don't think it was. It even existed then. That's the thing.
I see.
That library, the methods, the Shapley algorithm, of course it did, but that particular library didn't, which I think was the one that kind of, brought that to the masses, if you will. Um, so, um, yeah, unfortunately, I didn't use that.
I see. So actually, one of the interesting observations I made when you were talking about like white box and black box method was I'd read this paper long ago. I don't remember the title, but I'll send it to you later. But there was this interesting paper on how if you look at models that have distributions, underlying distributions, for example, linear regression, logistic regression, they tend to be they tend to be sort of weaker compared to models that have no underlying distribution. So then you have like random forests or decision trees or SVMs and whatnot. So although they are more opaque, they tend to be more powerful. And there was a statistician who was arguing. I think he was the founder or he was the inventor of random forests. His argument was that statisticians should, start using some of these models, although they don't particularly give you information about what are the most relevant variables and whatnot. I mean, of course, now we have tools now, but we didn't have those tools back then. So it's interesting to see that. I think probably in the statistics community, this is a conversation that they've probably been having for a while, because it's very easy to interpret a linear regression model. It's much harder to do that with a tree ensemble or a SVM and whatnot, right?
Yeah, yeah. There's a lot of debate about that, and there's people in a camp that are like saying it's immoral to use anything that is black boxy, and I mean, it definitely depends on the use case. I think
Yeah,
there are areas that are simply um, ethically untenable
yeah,
for
yeah,
any model. I mean, very, very hard decisions like, you know, the kind of decisions maybe a judge makes or a doctor. Although, I mean, it, it it really depends on the risk and the reward you
yeah,
get from these things. So, um, I think in some cases there could be so much bias on the human side. It makes sense to have some kind of assistance, you know, be it from a white box or a black box model, it's irrelevant. It's just how much more accurate it is than a human.
yeah,
Like we could go around in circles saying, well, like, what if these self-driving cars kill people? And
yeah,
and my answer to that question is, well, does it kill less people than, and it's probably a very utilitarian response than a human does, than humans do. And it's likely the cars are far better at driving than machines are so much better at driving cars than humans are. It's completely possible. The thing is, yeah, we don't have enough data for that yet to make that determination.
yeah,
And
yeah,
and and so I think it's for the betterment of society. Of course, like when it comes to accountability, one of the things that accountability does is, when you have responsibility, there's some kind of retribution. So like self-driving cars should be insured, you know. Maybe if we don't trust them that much, they should be insured even more strongly than
More
humans
than,
do.
yeah,
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 fine, fine. But I mean, then they're covered should something happen. I
yeah,
mean, obviously it's not something that will solace a person that lost a loved one because of self-driving car, but I mean, it happens with people
yeah,
far more
yeah,
often than it should, and it's probably happening more now that people are constantly distracted with their phones.
yeah, yeah. Yeah, I think that's like with the self-driving debate, I think that's one of the funny parts is that people are okay if it's, if it's a person who hit someone, and then like the point is you can still hold that person accountable, you can put them to jail, put them in jail, you can, say or do whatever. But with the self-driving car, the challenge just tends to be, just because it's a machine, like whom do you ultimately hold responsible, right? Like
Yeah,
that's I think very, very difficult challenge that everybody, and this is not just for self-driving cars, right? Like for any system,
yeah.
yeah. So the other thing that I'm thinking about is how do you uh, how do you essentially ensure that there's very little bias in your data, right? Like, do you have any thoughts on that?
How do you ensure that there's less
There's,
bias on the data?
yeah, yeah,
Um, and there's metrics. I
yeah,
mean, there's so many different metrics for it. There's a lot of debate on which metric is better. It all depends on your problem, on the distribution of the population, on who's the privileged group and who's the underprivileged group, and how they're privileged or underprivileged, and
yeah,
and and how dire that is.
yeah,
Like, again, this is very utilitarian, but you can put a cost to it, You can say, what is the cost of making a wrong prediction, that puts a person in jail, you know, and versus what is the cost of leaving them out and the risk of them, being on the streets and causing harm. Like you could put a cost to that and really measure it out and
yeah,
see,
yeah,
well, of course, obviously, time and time again, you'll find that the risk of unfairly incarcerating a person is, and the cost of that is super high
super
if you
high, yeah,
value human life. And so you're going to want to really penalize false positives in a case
yeah,
like that.
yeah,
And that's what makes sense. So when discussing fairness metrics, you take that in account, and that is factored in the equation. So I think a lot of equations that deal with fairness, there's some that go into things like that. There's some that deal with intersectional issues, like they're not only looking on a privileged and underprivileged group. They're looking at a whole like crosstab of different people. Male, female, different races, and different incomes, and so on. They're just
yeah,
looking at the whole thing and seeing how unfair it is as a whole. Of
yeah,
course, like it's very complicated. I was recently like in a conversation about this, and a person was saying, "Well, it's been known that I I know for a fact that women are less likely to be incarcerated, and they're altogether less likely to commit a crime. That's why they're less likely to be incarcerated." But this other person told me the argument that, oh, well, but it's also proven that judges are more lenient towards women
yes,
because they
yeah,
have children at home and whatnot. So there's also counter arguments on what is the fair thing to do.
yeah,
I don't know. I never saw that angle, and honestly, I'm completely in favor of women staying home and taking care of the children. They're single women and single parents. I mean, I don't see how that would be bad for society. But again, I mean, it's just it's an issue that's not only involves practitioners such as ourselves, but also ethicists. And I
yeah,
don't claim to be an ethicist or a psychologist or a sociologist or any of those things. I rather, shift the burden onto them to come up with the best answers of what is fair or not. And
yeah,
I just plug in their idea of that in my models because
yeah.
they'll know better.
That's one of the reasons why I was intrigued by the pyramid that you showed, because the exact situation that you mentioned, I've had conversations along those lines where, it's very difficult for a data scientist or really anyone who works with data to make those decisions about data, about what is fair, what is not fair, right? In the long run, it's extremely hard for us to make those decisions, and even for ethicists to do that. It's it's not like, none of these things are all like ever like black and white answers. They're always
Yeah.
grays, right?
Yeah.
So
Well, I think it's better to consider them than to not. Like right
yeah,
now, like we're in machine learning, no matter your problem, you're chasing after a single objective function
yeah,
with no kind of consideration of externalities of any sort.
yeah,
And the thing is, well, ideally this would include like the baked in the objective function, fairness, and a whole host of other things
yeah,
that are important. Like maybe you have environmental costs,
yeah,
carbon footprint in there. It really depends on the problem, but you want to have something beyond like the bottom line
yeah,
involved in your metrics.
yeah. That makes sense. That makes sense. Yep, awesome. With that, I would like to close today's event. We're on time. So yeah, so in closing, thank you, sir, for talking about interpretable machine learning. I think we learned a lot out of today's session. We had a few questions, so thanks for the audience for asking questions and being active with that. So yeah, I mean, and I really hope that we can keep continuing this conversation. I think this is a really important conversation, and going forward, as more people are involved in this field and more people start talking about what is interpretable machine learning, they start implementing it and they start using it. It's really, it'll be great, because I think we'll learn a lot more about how to build models, not just to make, of course, we all want to make our startup successful. We want to make our companies grow, but also at the same time to make sure that we create sort of a more equitable society in this whole process. So thank you, sir. Thank you for being here, and thanks to the audience as well.
Thank you,
Thanks.
everybody, for joining.